In example 14.10e, we've been given function g. G of x equals x to the fifth plus 9x cubed is the equation. Let's write down the end behavior. As, let's see, y approaches infinity, as x approaches positive infinity, and y approaches negative infinity as x approaches negative infinity. And I need to give a little more detail than I have on the others here with the x-intercept calculation. I'm going to go ahead and work this all the way through so you can see it. When we factor g of x, we're going to take out a GCF of x cubed, leaving us with x squared plus 9. And I recognize that the x squared and 9 are perfect squares, but it's not a difference between the two perfect squares, it's a sum. And we don't have a nice factoring technique for that when we're using integers. So don't try to force any more factoring on this. Go ahead and go straight to calculating the zeros. Let g of x be equal to 0, and then you're going to get 0 is equal to x, or 0 is equal to x squared plus 9. So that first result, 0 equaling x, is going to result in the origin as an x-intercept. And since x is actually being cubed in the equation, you can see here x is to the third power, that means we have a multiplicity of 3 on that particular x-intercept. And then for 0 equaling x squared plus 9, I'm going to subtract 9 from both sides. So negative 9 is going to be equal to x squared. And then when I take the square root of both sides, I will get plus or minus 3i is equal to x. Those are going to be considered complex zeros, and if they're complex, then they're not real. So I'm not going to worry about trying to force anything else with those. So really the only x-intercept we have is going to be at the origin. Your y-intercept calculation is also going to tell you 0, 0. And then as far as your symmetry is concerned, this will turn out to be nice enough to be an odd function, which we've seen implies origin type symmetry. I only have one x-intercept and y-intercept to mark. My end behavior on the right is going up, end behavior on the left is going down, and now I want to be able to connect the arrows with the single point that we have. And we recognize that there is a multiplicity of 3 on the origin, and there's only one of two ways to make that flattening occur. Since we're going to be starting from the left end behavior going up, I'm going to make this version of the multiplicity of 3 at the origin, and I'll use that to connect to both the left and the right end behavior, and that gives us the graph of G.